Good morning. Today we'll complete the topic logic, or if required, we'll utilize 15-20 minutes of the next lecture also. First sum is sum number 3. Let me explain. You can write the solution after the lecture. All these are simple sums but important. Write the truth values of the following statements. First one, root 5 is an irrational, but 3 root 5 is a complex number. Clearly, this is not a simple statement. Now, solution, let P denote root 5 is an irrational. Q denote 3 root 5 is a complex number. So, what is the symbolic form of the given statement? P and Q. Clearly, statement P is true, but statement Q is false. So true and false, which is nothing but false. So what is the truth value of the statement? It is nothing but F. This is not at all difficult. Second, for every n belonging to set of natural numbers, n square plus n is even number, while n square minus n is an odd number. So in the second, let P denote for all small n belonging to capital N, n square plus n is even, and let Q denote for every n belonging to set of natural numbers, n square minus n is an odd number. Then the symbolic form is P and Q. Now statement P is true. You can verify that. And statement Q is false. So the given statement is P and Q, and what is true and false? It is nothing but false. We'll come back to the first one. This is ambiguous in the sense 3 root 5 is a complex number. Every real number is a complex number. So in that sense, 3 root 5 is a complex number. So ideally, they should have given purely real or something like that. So at present, they have given this solution, but we will definitely discuss on this later on. In the textbook also, they have given this answer only, F. But every real number is a complex number. So in that sense, this is true and true, that is true. But let us discuss on this afterwards. Then, sum number 3, for some n belonging to n such that x plus 5 is greater than 10. This is third one. Yes, this is a true statement. In fact, for all natural numbers greater than or equal to 6, n plus 5 is greater than 10. So the truth value is nothing but T, which is the fourth statement. The square of any even number is odd, or the cube of any odd number is odd. Fourth one. So let P denote the square of any even number is odd. Q, the cube of any odd number is odd. Then the symbolic form is what? P or Q. Now the statement P is false, but statement Q is true. So false or true, that is true. So what is the truth value? It is nothing but T. Fifth one, in triangle ABC, if all sides are equal, then its all angles are equal. Let P be the statement ABC is a triangle and all its sides are equal. Q be the statement all angles are equal. So the symbolic form is P implies Q. If the truth value of P is true, then the truth value of Q is true. So P implies Q is nothing but true. And the last one, for all natural numbers, n plus 6 is greater than 8. Clearly, this statement is false. For example, n equal to 1 plus 6, 7 greater than 8? No. 2 plus 6, 8 greater than 8? No. So the statement is false and its truth value is nothing but F. Actually, I was thinking of giving these sums for homework, but let us discuss solutions of 4 and 5 in short. Set A is 1, 2, 3, 4, 5, 6, 7, 8, 9. Determine the truth value of each of the following statements. Now see whether you can do this on your own or not. Or you can try this after the lecture. These are the answers. Fifth one. Now this type is important. Write the negations of the following. For all n belonging to A, n plus 7 greater than 6. Now for every, in the negation, instead of universal, we use existential quantifier. So there exists at least one n belonging to A such that n plus 7 not greater than 6. This is sufficient, but not greater than 6 means less than or equal to 6. See, you can write any of these two. Second, there exists at least one x belonging to A such that x plus 9 less than or equal to 15. For every x belonging to A, x plus 9, you can say not less than or equal to 15 or greater than 15. Third one, some triangles are equilateral triangles. All triangles are not equilateral triangles. Seventh question will be doing only fourth part. Determine whether the following statement patterns are tautologies, contradictions, or contingencies. Fourth one, the statement pattern is P implies Q implies R, biconditional P and Q implies R. So these many columns are to be made. As 3 statements are there, simple statements, 8 entries in all. Now it can be seen that all entries in the last column are T. So the statement pattern is a tautology. Sum number 8. This type is again important from board exam point of view and from CET point of view also. Determine the truth values of P and Q in the following cases. First one, P or Q is true and P and Q is true. Now P and Q is true in only one case. So in CET you can directly say TT, but in board exam, if this sum is asked for 2 marks, then you have to mention all the 4 combinations. In fact, we have to construct this truth table. Now P or Q true, P and Q true. So truth value of P is true, truth value of Q is also true. So this is the first part. Better. Now second sum, P or Q is true and P or Q implies Q is false. This happens only if P is true and Q is false. So this is for the second one. Now sum number 3, P and Q is false and P and Q implies Q is true. So for these 3 combinations, these 2 results hold good. So you have to write that possible truth values, P true and Q false. Second possibility, P false and Q true. Third possibility, P false and Q false. Now again, this type is important. Using rules in logic, prove the following. Number 1, P biconditional Q logically equivalent to not P and not Q and not Q and not P. Let me explain, but you had to write this solution here only, not after the lecture. Okay, so by the rules of negation of biconditional, what is negation of P biconditional Q? P and not Q or Q and not P. So can I say that negation of this is nothing but P biconditional Q? Yes, I can. Negation of negation is original statement. Now, let me explain. This is basically negation of disjunction. What is negation of disjunction? It is conjunction of negations. Now what is negation of P and not Q? It is nothing but, we need not simplify this. This is the required answer. I repeat the solution. We begin with, this is the rule of negation of biconditional. Again, we take negation. So negation of negation P biconditional Q is P biconditional Q. Sides are interchanged. And on left hand side, it is negation of this. Now only one step. Negation of disjunction is conjunction of negations. Now we have to prove this only. Right. Second, not P and Q equivalent to P or Q and not P. So we begin with this P or Q and not P. Use a distributive law. So it is P and not P or Q and not P. Now P and not P is what? Definitely it is false complement law. What is false or this? It is nothing but same Q and not P. Reason? Identity law. Now can I say that Q and not P is equivalent to not P and Q? Yes, commutative law. So we have proved that not P and Q is equivalent to P or Q and not P. Third one, prove that negation of P or Q or not P and Q is equivalent to not P. So we begin with this. Now it is negation of disjunction. It is conjunction. See the cursor. Conjunction of negations. Now not P and not Q or not P and Q, use distributive law. So it is not P and not Q or Q. Not Q or Q is definitely true. Complement law. And what is not P and true? It is nothing but not P. Identity law. Sum number 11 is for homework. Using the rules in logic, write the negations of the following. I have given the answers. Now, sum number 12 is again for homework. Express the following circuits in symbolic form. Prepare the switching table. So this is the symbolic form of the first. If you make the table, entries in the last column should be 1, 1, 1, 1. This is symbolic form for the second, and these are the entries in the last column. Sum number 13, simplify the following so that the new circuit has minimum number of switches. Also draw the simplified circuit. First part, actually, you have to begin with let P denote the switch S1 is closed, because in the diagram they have given S1, S1 dash, etc. So how can we directly write PQR? So first we have to define Q, the switch S2 is closed, not P, not Q, and so on. And then you have to say the symbolic form is, it is what? P and not Q, or not P and Q, or not P and not Q. Now associative law, consider these two. Then use distributive law to get what? Not P and Q or not Q. What is Q or not Q? True. Complement law. What is not P and true? Not P. Identity law. Then use distributive law. This step is important. See, application of distributive law. You have to be very careful. Now, what is P or not P? It is nothing but true. Reason? Complement law. And finally, it is not Q or not P. Now, you may say this is negation of disjunction, rather conjunction. Yes, you are right. Negation of conjunction. But we keep this as it is. So, this is the simplified circuit. Because what is not P? Not P means the switch S1 dash is closed. That is, switch S1 is open. Now in second, you have to begin with let PQRS denote switch S1, S2, S3, S4 are closed respectively. In fact, one more, T, small t. Okay. So this is the symbolic form. It is lengthy but not difficult. Now it is not R or not S or not T. By Morgan's law, it is not R and S and T, right? So first step, De Morgan law. Now distributive law. So P and Q, not R and S and T, and R and S and T. This is nothing but false. Complement law. See, any statement has its conjunction with its negation. So it has to be false. Now P and Q are false is nothing but P and Q, because whatever is the truth value of P and Q is the truth value of this. Had it been P and Q or T, answer would have been T. Had it been P and Q and F, answer would have been F. Now this is P and Q, reason identity law. So only two switches in series. So this is the simplified circuit. 14th, check whether the following switching circuits are logically equivalent. Justify. See, can you tell me this directly? This is what P and Q or R. P and Q or R. And what is the second? It is P and Q or P and R. See, they are equivalent. Why? Because of distributive law. Just a minute. See, you have to begin with P, Q, R, etc. Symbolic form of the given switching circuits are, first is P and Q or R, and second P and Q or P and R. Now, by distributive law, P and Q or R is equivalent to P and Q or P and R. Hence, the given switching circuits are logically equivalent. What about second sum? Can you tell me the symbolic form of this? Basically, S1, S2 in parallel, so P or Q, and in another bracket, P and R are parallel, so P or R. Okay, and what about second? It is P or in bracket Q and R, because S2, S3 are in series. But note that again by distributive law, P or Q and R is P or Q and P or R. So the switching circuits are logically equivalent. See, it is not necessary that they should be logically equivalent, but here they are. Another possible method is you construct the switching table, right? But here, using laws of logic, we can easily verify that these are logically equivalent. Try 15th at home. This is the simplified symbolic form, P or Q and R. So two switches, S1, S2 in parallel, and the switch R is in series combination with this parallel combination. Now 16th is simple one. You will notice that throughout disjunction is there. So one of the statements is not P, other is P. And what is not P or P? True. True or is always true. So the current always flows. It is not necessary to use any switch in the circuit, right? You may say, actually, if you want to write reason, then commutative law, associative law, and here complement law. But this is true, so identity law. Again, identity law. So you have to say that current always flows. It is not necessary to use any switch in the circuit. This is simplified form of the given circuit. Right. Now last sum of this topic. Represent the following switching circuit in symbolic form and construct its switching table. Write your conclusion from the switching table. This will be asked for 4 marks. So strictly you have to begin with this only. Otherwise they have given S1, S2, S3. So how can you directly say PQR? So first you have to define. Let P stand for switch S1 is closed and so on. What is the symbolic form? P or not Q or not R, and P or Q and R. So this is the switching table. I hope you can construct this table. Now observe the entries in the last column. From the table, the final column and the column of P are identical. See, first column 4 times 1 followed by 4 times 0. Same here. Hence, the given circuit is equivalent to the simple circuit with only one switch S1. So the simplified form of the given circuit is this. Is that clear? So we have completed the topic. Please do solve sums given for homework. Tomorrow we'll start with the next topic.